So JEE Mains January 2026 from alcohol phenol ethers, the questions which I am going to discuss right now. So the question number 1, so it is a statement type of question they gave us. So phenol on treating with chloroform in presence of base, obviously this is a Riemann-Tiemann reaction. Here is asking para product is major, the statement 1, and statement 2. So the mixture orthohydroxybenzaldehyde or orthosalicylaldehyde and parasalicylaldehyde, so we can separate by through the stream distillation. Of course this is correct. So we'll discuss what exactly in detailed mode. In detailed mode we'll discuss this reaction when phenol is treated with chloroform in presence of base. We'll get orthohydroxybenzaldehyde plus parahydroxybenzaldehyde. Orthohydroxybenzaldehyde and parahydroxybenzaldehyde. Here this is orthohydroxybenzaldehyde. Here is intramolecular hydrogen bonding is there. Intramolecular. This is important in the same question, intramolecular hydrogen bonding. Because of intramolecular hydrogen bonding, this is the stabilizes. This is the major product, madam. This is a major product. This is minor product. So generally in electrophilic substitution reactions, para product is major, but in this case particularly, because of intramolecular hydrogen bonding, so ortho is major. In the statement 1, they told us parahydroxybenzaldehyde is major. The statement 1 is false. And in the statement 2, they are asking, so both we can separate it by the steam distillation. So obviously we can separate it by the steam distillation because here is intramolecular hydrogen bonding, whereas in this case intermolecular hydrogen bonding. Intermolecular hydrogen bonding. So particularly when intramolecular hydrogen bonding, it's so the between the molecule there is no bonding. So easily they can evaporate, easily they can volatile. So but whereas in this case intermolecular hydrogen bonding, so strong bonding in between them, so this is less volatile when we compare with this. So we can separate by the steam distillation. So answer, we will back to the answer. So statement 1 is false, statement 2 is true. So statement 1 is false, statement 2 is true, Nana. So option 4, fourth option is the correct one. So this is wrong, this is right. We'll go to the second question. So one more question from alcohol, phenols and ethers from JEE Mains January session. So this is, combination of 2-3 reactions and very important. When ether is treated with excess of HI, hydrogen iodide, so then afterwards aqueous NaOH, so then yellow precipitate NaOI means iodoform test. So 3 reactions are given. One is nucleophilic substitution reactions and identification test, nothing but iodoform test. So we'll discuss what exactly. So first we'll take this option 1. So reaction with ethers with hot HI and cold HI. Reaction with ether, 2 types of reactions are there. One is hot HI or we can say excess HI. Excess HI. So one more type of is there, that is normal HI, otherwise we can say cold HI. Cold HI or simply HI. If they didn't mention anything, so we need to take the cold HI. In this case, hot HI and cold HI cases, in case of hot HI, excess HI, both are converting into alkyl iodides, Ri plus R dash I. Either that is symmetrical or unsymmetrical, doesn't matter, both are converting into alkyl iodides. Whereas in case of cold HI, so one is converting into alcohol and one is converting into alkyl iodide. So this reaction also very important. Probably in the April session they may ask this question. So I'm not speaking about that much right now because I'm explaining this question. So here is, this is the answer, which both are converting into iodides. So particularly in this case, if I'm going to the option 1, option 1 is like this. Option 1 with excess of HI with excess, one is converting into ethyl iodide and one more is converting into this one, 2 iodine. So iodine is coming over here as well as here. This is the first step. They ask this the first step, and when we treated with these two, alkyl iodide as well as this, with aqueous NaOH, So it is nucleophilic substitution reaction takes place. Iodine is replaced by the OH group. OH, and here is also OH. When it's treated with NaOI, so we'll get CH3 iodoform and HCOO-Na. It is also CH3 plus remaining as a byproduct. This is alloform or iodoform test. In this case, for iodoform test, we need to know these 2 points are important. First point which we need to understand, methyl ketone. Aldehydes and ketones, particularly aldehydes and ketones which are having this one, methyl ketone, will give the iodoform test, the point number 1. And all 2-ols, alcohols, all 2-ols also will give the iodoform test. And of course ethanol also will give the iodoform test. So just remember these 3. Obviously this is ethyl alcohol and this is all 2-ols gives the test. So means, so both option 1 is satisfying by default. Option 1, so this is a compound is satisfying. So answer will be directly, we can go with option 1. So if you can cross check with this one, here is ethanol is one is forming but second one is won't form because that is a phenyl group. In this case also it's not possible, so option 1 is correct. One more easy question from alcohol phenol ethers. So simply they are asking how many compounds containing at least secondary alcohol. Simply, so we need to know if alcohol, if it is attaching with this carbon, this is, we can say, primary alcohol. Secondary alcohol means the OH group which is directly attaching this carbon should attach the 2 carbons. If it is attached, this is secondary, 2 degree. And if it is the carbon is attaching with 3 carbons, the OH group attached carbon, this is 3 degree. But simply they are asking how many 2 degree carbons are alcohols, how many secondary alcohols are present in the following compounds. If you can cross check in the first one, this is primary alcohol. So obviously, so no secondary alcohol. But whereas in this case, this is secondary alcohol. This is primary, but doesn't matter. Here is alcohol is there, but this is 3 degree. 3 degree. So no, they are asking only 2 degree. And here also 2 degree is there. And this also 2 degree. This is 3 degree. Both are there. 2 degree as well as 3 degree. But they are asking only 2 degree. And in this case, 3 degree, 3 degree, 1 degree. So how many? 1, 2, 3. So 3 is the answer. Option 2 will be the answer. Simple and easy question. So primary, secondary, tertiary. Sometimes this type of easy questions also they are asking. But this is one type of trapping question. Because sometimes this type of alcohols in the examination stress. So we may confuse. Okay. So just be careful when the easy questions are coming. So one more question is a combination of alcohols, phenols, ethers as well as aldehydes, ketones. It is asking Tollens reagent. Particularly n number of 90% of students, they know that aldehydes will give the Tollens test but not ketones. Because Tollens is a weak oxidizing agent. So aldehydes will react with this Tollens reagent, it's forming the carboxylic acids. And silver mirror is forming, of course, silver mirror test. But particularly in this case, so they didn't give us any aldehyde, but they didn't give us any ketone. They gave the hemiacetal. So we should know what exactly hemiacetal and acetal. For example, if you imagine if one aldehyde is there like this, if I am treating with alcohol. So if alcohol is coming and talking like this, so CH3, directly I am writing the product, HOR. So this is, we could say, hemiacetal. If you are treating with one more alcohol, it becomes acetal, of course. So first we need to cross check whether the hemiacetal is present or not. So particularly in this case, this is hemiacetal is present. What exactly happens? The reverse reaction takes place here. Reverse reaction means what? If you are using the base, let it obstruct the proton. And this is coming here, so backward reaction takes place. We will get aldehyde as well as reverse reaction takes place. So here in this case, O minus and C double bond OH, aldehyde is forming. When aldehyde is forming, it gives the Tollens test. So, but remaining there is no any hemiacetal. This is the option. C will be the answer. So direct question. But combination of reactions they are asking, we should be very careful. So one more question. This question is a combination, from alcohol, phenols and ethers and carboxylic acids. Here is directly one compound X is given. So here is carbon 76.6, hydrogen is 6.38% and vapor density is 47. So molecular mass is equals to 2 into vapor density. So molecular weight is equals to 2 into vapor density. So 2 into 47. So obviously we'll get 94. And when it's treated with CO2 NaOH at high pressure and after acidic medium, it's very simple. It's a coal-based reaction. What is a coal-based reaction? When phenol is treated with CO2 in presence of base, we will get orthohydroxy benzoic acid and parahydroxy benzoic acid. Orthosalicylic acid and parasalicylic acid. So in this case, so C6H6O. Right? So it's matching with phenol obviously. So molecular weight and everything, carbon percentage and oxygen percentage and all. So now the compound Y develops some characteristic color with FeCl3 solution. Identify the incorrect statement. So it's very important. They are asking incorrect statement. Both compounds X and Y will dissolve NaOH. By default X and Y, so means this is X. Imagine I am taking the Y major compound, of course. Both are dissolving in the NaOH. This is the correct one. And the compound Y will dissolve in the NaHCO3, evolves a gas. By default, NaOHCO3 carboxylic acids will dissolve in sodium bicarbonate. So the second one also is correct. And compound X is more acidic than Y. Generally, phenol is less acidic than carboxylic acids. This compound X is more acidic than, this is wrong, Nana. Y is more acidic than X. So third one is wrong. Both compounds X and Y burn with sooty flame. Generally, aromatic compounds, when we are burning, so it gives a sooty flame, like black color flame is forming. So this is also is correct. By default, what is the answer? Answer will be the third one. Incorrect statement. They are asking the questions from different combination of chapters. That's the reason from alcohols, phenols and ethers I took only 5 questions, and remaining questions I'll do in a chapter wise. Thank you.